All right, ladies and gentlemen, welcome back to the second day of calculus. We are going to start off nice and strong with some properties. So if we're trying to find the limit of a number, so say the limit as x approaches c of b, that limit is simply that number. So for example, if I'm looking for the limits as x approaches to of 3, my answer is simply 3. Say I'm looking for the limits as x approaches some number of x, my answer is just going to be c. So when I'm asked to find a limit of an x value or a sum unknown, all I simply do is plug that in. So if I'm looking for the limits as x approaches -4 of x, again, I simply plug in whatever value I'm looking for, and that's just my answer. Last one, if I'm looking for the limit as x approaches some number of x to a power, then all I do is likewise, I plug that number in and I take it to that same power. So say I was looking for the limits as x approaches 2 of x squared. Well, I'd plug in that 2 for my x value, and it's still to the second power, so 2 squared ends up giving me 4. Okay, so we have some more properties we need to talk about now that we kind of get the gist of them. So if I tell you that the limits as x approaches some number of c of f of x is going to be capital L, and I also let the limits as x approaches some number of g of x, meaning a second equation, is equal to k. So whatever, doesn't matter what that function is, doesn't matter what f of x is, doesn't matter what g of x is, they're both going to give me some value. So I'm going to call the first one L and the first one k. And we're going to go ahead and talk about these. So if I'm finding the limits as x approaches some number, and that's b times my f of x function. So that means I have the function 2x plus 3, and I have a negative 2 on the outside. I'm going to multiply that through. It's the same thing as saying I'm going to take b times that L. So we had said L before was whatever that limit value is, depending on what I'm looking for. So basically, I just take that scalar multiple and also multiply it to that limit. So if say I'm finding the limit as x approaches c of f of x, either plus or minus g of x. Now it does not matter which order. Say I'm adding, I'm subtracting. Say I'm adding f of x and g of x, or I'm subtracting them. It does not matter which one. Then it is the same thing as saying my limit value plus or minus the other limit value. Okay, let's go ahead and talk about the product rule. So I'm taking the limit as x approaches some value of f of x times g of x. Then that product is just going to be L times k. Quotients mean division. So I take the limits as x approaches c of, it doesn't matter which one. So say I say f of x divided by g of x. Then that would be the division of those two values. Likewise, if I switched g and had g on top and had g of x divided by f of x, then my answer would be k divided by L. And conversely, should I say lastly, my apologies, if I take the limit of x approaching c of f of x to the nth power, it's the same thing as saying L to the nth power. So the whole point of these first two slides is because whatever I can do basically with a number or one expression, I can also apply to any function. All right, let's go ahead and practice with this. So my first example is the limit as x approaches 2 of 4x squared minus 3. So I can split this up and say the limit as x approaches 2 of 4x squared minus the limit as x approaches 2 of 3. Okay, well this first one, I know that 4 is what's called a scalar because it's multiplying to my x squared. It's not, it doesn't have any variable in it. It doesn't have a variance to it. So I can pull that out because I know I'm still going to multiply. Whatever I multiplied my x by, I'm still going to be multiplying by 4 at the end. So limit as x approaches 2 of x squared minus the limits as x approaches 2 of 3. So kind of like if you're thinking about our logarithm rules, I'm kind of pulling out some stuff there. Well, now that I have x by itself, I have 4 times 2 squared, because I can plug that in now, minus the limit as x approaches 2 of 3, which we're finding the limit of 3, so it's just minus 3. So I have 4 times 4 minus 3. 4 times 4 is 16, minus 3. The limit as x approaches 2 of 4x squared minus 3 is 13. So essentially, all I did was plug in that value and solve. So, keeping that in mind, let's approach the second one. I'm going to find the limit as 5x squared minus 2 approaches 1. So we're going to plug 1 in. 1 squared is 1, so 5 times 1 is 5. So I get 5 minus 2, which is 3. Now, you're probably saying, well, wait, why didn't we get to do this yesterday? Well, yesterday, my limits had fractions, didn't they? I don't have denominators. I don't have numbers being plugged in that are going to make this not possible. I can plug in 2. I just want to see what it's getting close to. I can plug in 1. I'm not going to plug in a value and get an unknown answer. All right, next we have a theorem. My theorem says that if r is a rational function given by r of x, and that is equal to p of x over q of x, so I'm essentially saying I have 3 equations now, and c is some real number such that c of q is not equal to 0, because again, we don't allow 0 on the bottom. Then we can plug everything in. So this is saying that now that we've applied this to regular functions, when they are possible, given that value, I can now also associate it with fractions as long as that limit number does not make it not possible, does not make it undefined. So if we look at these first 2 examples, I'm trying to find the limit as x approaches 1. Well, if I plug in 1 here at the bottom, that's not going to give me 0. So because it is not going to give me 0, I can just plug 1 in for x. Oops. Said x and 1 at the same time. Tried to write them together. So then I have 1 squared plus 1 plus 2 over 1 plus 1. 1 squared is 1 plus 1 plus 2 over 2. Which eventually gives me 4 on top over 2. 4 divided by 2 is 2. So the limit as x approaches 1 of x squared plus x plus 2 divided by x plus 1 is 2. It did not have a denominator that would get to 0 if I plugged in 1, so therefore I can plug it in. All right, last example. Let's take a look. If I plugged in 2 in the bottom, is that going to give me an undefined answer? Nope. Okay, so let's plug it in. So I have 2 squared plus 2 times 2 plus 6 all over 2 plus 3. 2 squared is 4. 2 times 2 is 4. Plus 6 comes with. Over 5. 4 plus 4 plus 6 gives me 14. Over 5. It's not easily reduced. It makes my life harder if I turn it into a decimal. My answer is 14 over 5. Alright, that's all I got for you. See you tomorrow.